Newton's. We are looking at law of conservation of momentum. So we already know Newton's third law of motion. Okay, and this comes from Newton's third law of motion. What is it? What does it state? Every action has an equal and opposite reaction. इसका मतलब ये हुआ कि ये दो ऑब्जेक्ट्स आपस में अगर टकराएंगे तो the force applied by 1 on 2 and the force applied by 2 on 1 both are equal and opposite. Okay, so now let's consider two objects. यहाँ पर object 1 and object 2. So 1 का mass है m1 and 2 का mass है m2. The velocities which they are approaching each other is, initial velocity is u1 and u2. Okay, so let's look at that. Okay, yes, the velocities with which they are approaching each other is u1 and u2. So we have mass m1 m2, velocity, initial velocity u1 u2, and then they come and collide with each other, right? On collision, we know that because of Newton's third law of motion, the applied force of object 1 on 2 and the force F2 of object 2 on 1 both are equal but opposite in direction. Okay, so because both have applied force on each other, there will be change in velocity. So whenever there is change in velocity, there will be acceleration. So one का acceleration लेते हैं a1 and object 2 का a2. अब जितने टाइम t1 यहाँ पर टाइम t1 और t2 दोनों का जितने टाइम पर वो कांटेक्ट में रहते हैं वो तो इक्वल होगा ही. So t1 is equal to t2. Now let us look at this. How much is this applied force? F1 कितना है और F2 कितना है देखते हैं. Okay, so according to, we start with Newton's law of motion. Okay, so when two objects interact, they apply equal and opposite force on each other. तो यहाँ पर collision पर F1 is equal to minus F2, right? The force applied by first object on the second, they are equal and opposite in magnitude. Now, according to the second law of motion, we know that F is equal to mass into acceleration. ठीक है, ये हमने ऑलरेडी देखा था फ्रॉम न्यूटन सेकेंड लॉ ऑफ मोशन. सो यहाँ F1 के बदले में हम लिखेंगे m1a1 एंड F2 के बदले में लिखेंगे माइनस वैसे ही रख के m2a2. अब एक्सेलरेशन जो है, एक्सेलरेशन इज yes the rate of change of velocity. Okay, that is acceleration. So we will, instead of a1 we will write v1 minus u1 upon t1 because acceleration is rate of change of velocity, and यहाँ पर v2 minus u2 upon t2. t1 और t2 सेम है इसलिए कैंसिल आउट हो जाएंगे और जो बचता है उसका हम we will open the brackets and solve it and we get this. What do we get? m1 v1 is plus m2 v2 is equal to m1 u1 plus m2 u2. इसको सॉल्व करने पर मिलता है. Now we also looked at momentum. हमने ये भी पढ़ा था कि momentum क्या है. Okay, so momentum is P is mass into velocity, right? So ये जो momentum दिख रहा है that is m1 v1 plus m2 v2 वो है total momentum after collision. मतलब टकराने के बाद, collision के बाद total momentum किसका? First body का and second body का, right? And now m1 u1 plus m2 u2 is the total momentum before collision. किसका? This is for the first body, this is the momentum for the first body, mass into initial velocity of the first body, and this is mass into initial velocity of the second body, m2 u2. So ये जो है total ये same है, right? That is equal. So after collision the momentum is equal to the momentum before collision. Okay, and this is what we know as law of conservation of momentum. Right? So momentum is mass into velocity और दोनों momentums that is after collision and momentum before collision दोनों equal है. Right? So this is the major application of the third law of motion. अब इसमें एक assumption ये जरूरी आपको नोट करना है कि there is no external unbalanced force. मतलब ये दोनों आपस में टकरा रहे हैं, इसके अलावा कोई भी एक्सटर्नल अनबैलेंस फोर्स नहीं है यहाँ पर. तो ऐसे केस में व्हाट इज द लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम? Yes, the law of conservation of momentum states that the total momentum after collision is equal to the total momentum before collision, assuming that no external unbalanced force acts on the system or acts on the bodies. Okay.